Hi everyone, this is Adam again. So today I'm going to go over financial maths and the amortization formula, present value, future value, interest, these sort of things. Okay, so it's one of the questions it comes up kind of every second year, in the Leaving Cert. So it's just it's one topic that kind of comes up as could be a short question or a long question. There was none in my year, but it could come up in the next year and so on and so on. Okay, so without further ado, I think we will just start with the formula. It's F equals P into 1 plus I to the power of T. So F is basically the future value of an investment. P is just the present value. I is just your rate of interest. And then T is just time. So basically, we'll see it in a while, but for this little part here, it's kind of like what you're saying is you're saying that in the future, it'll be worth the present value multiplied by your 1 plus I to the power of T, which is kind of like your interest rate that you're getting on your present value. And then you just multiply it and then you get it. Okay? So we could do something like this. So let's say you have 40,000. Sorry. You have 40,000 and you want to invest it, and you're going to invest it at a rate of interest of 10% for 4 years. Okay, and then basically what they're asking is they're saying, okay, well, how much money will you have at the end? Well, you can say in the future, that's going to be the present value, which is 40,000, multiplied by 1 plus I. Now be careful. I has to be written in decimal form. So 10% is 0.1. So again, if you're not sure, just divide it by 100. Go into your calculator, do 10 divided by 100, you'll get 0.1 or a tenth. That's where this number comes from. And then you're doing it for 4 years. Okay, so it's just equal to 40,000. 1.1 to the power of 4. So in the future, it's going to be worth 58,564. Like this. Okay. So not too bad. One thing to just be careful of is these two numbers here. So your present value and future value are kind of obvious when you're plugging into the formula. Your rate of interest and time mightn't be. So if they give you the rate of interest and they say this is the yearly rate of interest, then T needs to be in years. Okay, and if they say, and this is your interest rate is 1% per month, and it's going for 4 years, in that case, you'll have to change T to months because your interest is in months, and therefore your time has to be in months. Okay, so just be careful when you're doing this part. They need to be in the same time. So if your interest is per year, then this has to be in years. If this is per month, then this is in months. Okay, so that's the only thing to be careful about there. All right. Okay. So that's kind of everything there. We could also, I'll just do another example. Another thing that comes up is APR and AER. So APR, AER, for all purposes in the Leaving Cert, this is just interest. So if they tell you the AER is 3%, that just means that the interest I is 3%. So that's all you have to think of there. They're just using different words, but as long as you, in your head, you say, okay, the second you see APR, it's just interest. And be careful, the A stands for annual. So it's just, this is an annual rate of interest, so per year. Okay, so just be careful with that, all right? So now we can do an example. So it says 15,000 is invested at an AER of 3%. So you have 15,000 and it's invested at 3%. Then it says, what's the value of the investment at the end of year one? So you say, great. So your future value is equal to your present. So remember, I just p into 1 plus I to the power of t. So in this case, your future value is going to be your present, which is 15,000. So you've invested 15,000. 1 plus I, so I is 3%, that's 0.3. 1 plus 0.3 is 1.03. And how long is it in there for? It's in there for 1 year. So remember, this interest rate is AER, which is annual equivalent rate, but it's just annual interest. So it's at 3%, okay? And it's for 1 year. If they said that the interest rate is 3% per month, then here I would have a 12 instead of a 1, okay? Because that means I'd have to do in months, not years, okay? So just be careful with that, all right? Plug this into your calculator, you're going to 15,450 euro, okay? And that's that. Then for the second part of the question, it says that 1,000 is withdrawn from this amount. The AER now is 3.5% and remains this rate for 3 years. What is the value of the investment at the end of year 4? So basically what happens is you have this, you take 1,000 out of it. So now you're left with 14,450 in the bank. That's how much is there. Now you have that your interest rate I is now going to be 3.5%, which is 0.035. And now it's going to stay there for 3 more years. And then they want to know how much is left. So again, your future value, F, is equal to P, which is 14,450, into 1 plus I, so it's 1.035. For how many years? It's there for 3 years. So it's just to the power of 3. Okay? And if you plug this in, you get it 16,020.97. Like so. And that's it. Okay. Now the next thing that I want to do is I want to show you how to, because basically in every single financial maths question in Leaving Cert, if it comes up, you almost guaranteed have to change interest rate, a monthly interest rate to yearly interest rate. Okay, or vice versa. So I'll just show you how to do that. Okay. So it says a loan advertisement quotes an APR, so again annual, of 14.9%. Find correct to 4 significant figures the equivalent rate of interest if compounded monthly. So basically what they're saying is the yearly is 14.9. What is the monthly? Okay. So what you're saying that, okay, well, the future value is equal to P into 1 plus I to the power of T. So just a very simple example. Your future value is equal to the present value into 1 plus I to the power of 1, where this is your yearly interest, which in this case, the yearly I is equal to 14.9%. So this is equal to P into 1.149. Okay, because again, it's to the power of 1, so that's just one thing. So I don't have to do anything about that. But I could also say, well, hold on, F is also equal to P into 1 plus, let's say, big I to the power of 12, where this is the monthly interest. Okay, so I can do this both ways. I can do it for the year, like so, or I can split it up into months and get this. Okay, and this is equal to P into 1 plus I to the power of 12. Now remember, these two things are equal. So if those two things are equal, that means that this has to be equal to this. Okay? So that means that 1.149, again to the power of 1, so 1 year, is equal to 1 plus I to the power of 12, where this is in months. Okay, so hopefully that makes sense, that obviously if what they're asking is, they're saying, well, what's the monthly compounded interest rate? Basically what that means is you should have the same amount of money both ways. So these are both equal to f. So if I do it yearly, I have this. If I do it in monthly, I have this. Now the thing is, I want to solve for what I is. So the capital I want to know what is that number. What you do is, you raise both sides to the power of 1 over 12. So again, this is back to your chapter of indices. On the left hand side, I get 1.149 to the power of 1 over 12. So remember, you multiply these two things together. Multiply these two things together, I get 1 plus I. So I get that I is going to be 1.149 to the power of 1 over 12 minus 1. If you plug this into your calculator, you will get that I is equal to 0.01164. So I is equal to 1.164%. Okay, so that is how you solve a question like this. So that's typically what they'll do. They'll give you a yearly one, which is this, and they'll ask you to find the monthly. Okay, so that's all you have to do. Okay, and then you get this. So this is definitely a thing worth practicing and worth knowing. Okay. The next thing to do is I'll just do one example of depreciation. Depreciation is just when, so an investment is when the value goes up, depreciation is when the value goes down. So all I have to do is just, if it's going down, it's f equals p into 1 minus I to the power of t. That is the only difference here. You just put a minus I instead of a plus I. So if the value is increasing, you put plus I. If the value is decreasing, you put minus. And that's quite literally it. Okay? So if I said, let's say you bought a van for 45,000 and it depreciates at a rate of 20%. What's the value in 3 years? You would say, okay, well, f is equal to the present value, which is 45,000, into 1 minus I, so minus 20%, that's 0.2. Okay? To the power of 3, because it's 3 years. So this is just 45,000, 0.8 to the power of 3, and that's equal to 23,000 and 40 euro. And that's it. So depreciation, I'm not sure if that's ever come up in the Leaving Cert, to be quite honest, but it's just there. You just put a minus I in front of it instead of a plus I. Okay. Now, for arguably the most important part of this chapter, the amortization formula. Okay. The amortization formula, what it basically does is it says, okay, if you take out a loan today at 100,000 and you're paying it back for 20 years, how much are your monthly repayments? Okay. Your monthly or yearly repayments. Now, typically it's monthly, so I'm going to act as if it's in months. Okay, but it could also be in years. So just please do be careful about that. If it comes up in an exam and they say, oh, what's the monthly repayments or what's the yearly repayments, that's two different ways of solving the question. Okay, so just be careful about that. So the amortization formula is this. It's your annual repayments are equal to the present value times I into 1 plus I to the power of t all over 1 plus I to the power of t minus 1. Now, A is again your annual or monthly repayments. P is the present value of the loan. So that's basically, that's how much do you take out. So you take out 100,000. So P is 100,000 or so on and so on. I is your interest. T is the time. And then A is just how much do you have to pay the bank back every single month. Okay. So this is actually how they calculate loans. So if you are, taking out a loan at something, you could just check that your monthly repayments are correct and they're not overcharging you with this sort of a formula. Okay. Now, you could also be asked to derive this formula. So derive basically means from scratch, where does this formula come from? And this has come up in the Leaving Cert, okay? So if it comes up, it is fair game. Now, do I think it's going to come up? No. But I am going to go through the derivation because I think once you see it done and you see, okay, this is where it comes from, this is what I'm assuming, this is what I'm taking into account, then it becomes much more obvious as to when you can use it, okay? And why you're using it and how you're using it. A lot of people get messed up with this formula and they don't like it because they don't know when to use it and when not to. But once I show you, where it comes from, it'll hopefully get much more obvious, okay? So the best way of describing this is you take out a loan today. And let's say in T years or T months, so again, I'm going to use months, so T months, from now, you're going to have the whole thing repaid. What is it going to look like? So here you take out P. Okay, so you take out 100,000. And then every month, you're paying back €1. So not a euro as in capital A euro. You're paying back that every single month and you keep doing it until you have everything repaid back over here. So now, when they say repaid, what does that mean? Basically, if the bank is saying, okay, now you've repaid us, what they're saying is, they're saying that the present value of the loan is equal to the present value of your repayments. Okay, so what's the present value of the loan? The present value of the loan is P. What's the present value of your repayments? So now this is a hard concept. So again, I'm going to explain this as best I can. So again, pause the video, think about what I'm saying. The present value of the repayments, basically what that's saying is, that's saying that yes, you're paying back €1. So let's just call it 100, let's say, you're going to pay back €100 in a month. Grand. But the problem is that €100 isn't actually worth €100 right now. Okay, so your money gets less and less valuable the longer time goes on. Okay, the way to think about this is you say, okay, well, fair enough, if I take out a loan and I say, okay, I'm going to pay it back next week, you might pay a £5 in interest, grand. But if you take 2 weeks to pay it back, you might have to pay a tenner back. So why is it you have to pay more? The reason you have to pay more is the bank is saying you have the money for longer and therefore we are going to charge you more for that service. Okay, so it might be a case of in a month's time you pay back €100, but as far as the bank is concerned, it's saying, well, hold on, you've had it for a week, so we're going to charge you €1 for holding it for that week. So we're charging you €1, and then the 99 that's left, that actually gets taken off your loan. Okay, then another week later, you pay another €100. They say, well, hold on, you've had this for 2 weeks, so now we're going to take away €2, and 98 goes towards your loan. So it's the 99 and the 98 and so on, 97, 96, 95. That's what actually gets taken off the loan. Okay, so that's what I mean by present value. It's like, because you're paying it back later, the bank is going to charge you money, and therefore the amount that actually gets taken off your loan isn't as much. Okay, so hopefully that makes sense. Hopefully it makes sense that obviously the longer you have the loan, the more you're going to have to pay. All right. So the present value of the repayments, what does that mean? So again, remember, future value is equal to present value into 1 plus I to the power of t. I'm looking for the present value. So the present value is equal to the future value divided by 1 plus I to the power of t. So in this case, the present value of the repayments. So remember, F in this case is equal to A, because F is what you're actually paying. So in the future, it's worth A. Grand. But you're dividing it by 1 plus I to the power of t. So P is equal to A over 1 plus I to the power of 1 plus A over 1 plus I to the power of 2 plus ... all the way up until the very last one. The very last one, the repayment is T months after, so it's 1 plus I to the power of t. Okay? So now hopefully that makes sense. That you're saying, yes, fair enough. In a month's time, you pay €1. But if I want to find the present value of that, I need to divide it by how long you've had it for. So you've had it for a month, and therefore I divide it by 1 plus I to the power of 1. Okay? And the second one, it's saying, okay, well, you've had this one for 2 months, so now I'm going to divide it to the power of 2. And so on and so on and so on. Okay? So in total, you have T repayments. Okay? So hopefully that makes sense. So that's how the bank calculates it. It says, okay, well, the present value that we're giving you is 100,000, but you're going to give us back, because just think about it, like if you take out a loan of €100 and then you only end up paying the bank back €100, there's no reason for them to give you the loan, because why would they give you the loan? They're saying, oh, here's €100, and in the end they get back €100. So why would they? There's no incentive for the bank to give out a loan, because all it's doing is it's lending you money and it's not getting any money in return. It's only ever breaking even. Okay, so that's basically the reason as to why you end up paying more than what the bank gives you. So it might be a case of if you take out a mortgage later in life, you might take it out for 200,000, but if you actually calculate the money that you give them, you might end up giving them back 220, 230,000. So the bank is basically saying that we're going to charge you an extra 20, 30,000 basically because we're giving you this loan. Okay, and that's how the banks stay in business, because of interest. Okay. So now what I want to do is I want to add up all these. Now, for some of you that may have watched my video on geometric series, this is just a geometric series. Okay, so Sn, so this is the summation for the nth terms. So in this case, that's S of t, because there's t of them. Okay, this is equal to, it's equal to, oh, this is embarrassing. I'm actually not sure. I think it's A into 1 plus 1 minus R. I think it's that. I might just check that, because that would be very, very awkward if I didn't get that. It says logarithms, length area, arithmetic. Sorry, this is very, very unprofessional. Number of patterns and sequences, geometric series is page 250. Okay. Again, these are in your log table, so you won't have to know these off. I'm very glad that I don't need to know them off. Yes, it's minus. Okay. So it's A into 1 minus R to the power of t all over 1 minus R, where R is what you're multiplying by, which in this case, you're multiplying by 1 over 1 plus I every single time. And A is the first term, which is in the green there. It's A over 1 plus I. Okay? So now, if I just plug those in, so P is equal to A, which is A all over 1 plus I, into 1 minus 1 over 1 plus I to the power of t, all over 1 minus 1 over 1 plus I. Okay, so let's multiply the top and the bottom by 1 plus I. That gives me A into 1 minus 1 over 1 plus I to the power of t, all over 1 plus I minus 1. Like this. So this thing on the bottom is just equal to I. So now I want to make A the subject of this equation. So I'm going to throw everything over to the left hand side. So multiply both sides by I and divide by this. So I get A is going to be IP all over 1 minus 1 over 1 plus I to the power of t. Multiply the top and the bottom by 1 plus I. the power of t, I get a is equal to p into I into 1 plus I to the power of t all over 1 plus I to the power of t minus 1. And that's the formula that we had. Okay, so that's basically what this formula is calculating, and that's why it's the way it is. Okay. All right, fantastic. So that's kind of that. Okay. So now I'll just do a couple of examples, and then I think we can leave it there for today. For this topic anyways of financial maths. All right. So what they're asking you is, so we're going to use this formula now in a second. It says, so you take out a loan at 60,000. So P is equal to 60,000. It says you have an APR of 3%. So remember, that's your interest. It said, how much should the annual, so again, it's annual repayments. If they said monthly, then you'd have to change the interest into months. Okay, and to do that, you'd say that your monthly interest, I, is equal to 1.03 to the power of 1 over 12 minus 1. That would be your monthly interest. Okay, so again, you can learn that formula off if you want it. But in this case, they want annual. How much should the annual repayments be if the loan is to be repaid in 10 equal installments over a 10-year period? So you have your annual repayments, A. Sorry, I never said that as well back up here. Sorry, you're paying the same every single time. Just in case I didn't mention that, it's always equal repayments. It's not like you're paying a tenner this week and then 20 this week. You're paying the same thing every single week or month or year. Okay, so just, sorry, I never said that. Okay, so A is equal to P, which is 60,000, times, so it's I, which is 0.03, into 1.03 to the power of t. So in this case, is to the power of 10, all over 1.03 to the power of 10 minus 1. If you plug all this into your calculator, you will get that A is equal to 7034. Okay? And that's it. All right? And again, just for clarity, if you did decide to say, oh, well, the present value, so go back up to this thing, up here, and you wanted to do the geometric series formula, you could absolutely do that. So you could also say 60,000 is equal to A over 1.03 plus A over 1.03 squared plus dot 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 A over 1.03 to the power of 10. So this is 10 because it's for 10 years. So that's the very last one. And then using your SN formula, you will get that 60,000 is equal to your SN, which is going to be, it's A into 1 minus 1 over 1.03 to the power of 10 all over 0.03. And then if you solve this, you would also get that it's going to be A into 8.53. And so A would equal 7034 as well. So either way works. Okay, but up here is just a bit simpler. Like once you have the formula, you just plug in the numbers, plug into your calculator, and boom, you're done. Okay. All right, I think that's that should hopefully be everything. So yeah, this is the 4th time that I'm recording this video after I've had some mishaps. So I think I've covered everything. I'm quite happy with this one. Okay, so I think I will leave it there for today. In the next chapter, it will be going over proof by induction, and then going over some complex numbers. So it'll be the next few steps are actually quite the next few chapters are actually quite interesting. So honestly, this has been the most boring part of paper 1. So we'll get into more interesting stuff after this. So I think I'll leave it there for today. So thanks very much for your attention, and yep, I'll see you. Bye.